Welcome back to the deep dive. So last time we gave you that first look at Windsurf, Cursor, and Klein, those AI coding tools.
We did. We just sort of scratched the surface, really.
Yeah,
And now, picking up right from there, we're going to dig in much deeper, specifically on the code generation side for Windsurf and Cursor.
exactly. Klein's really interesting, and we will get to it later, promise.
Mm-hmm.
But today, it's all at Windsurf and Cursor. We're really focusing on the code they actually generate. Like, can you use this stuff in the real world? Is it production ready?
That's the big question, right?
It is.
So, to get a good comparison, we gave both tools the exact same tasks. Started simple, then ramped up the complexity a bit.
Side by side, yeah. Should give you a pretty clear picture of, their strengths and maybe where they differ when it comes to just spitting out code.
Okay, so where did we start?
Right, the first test. A really basic programming task. A simple Python function.
Ah, the classic factorial.
The classic. The prompt was identical for both. Write a Python function called factorial that takes an integer as input and returns its factorial. Include docstrings. Pretty clear instructions.
Okay, and Windsurf, what did it come up with?
Windsurf gave us a recursive solution. Quite neat, actually.
Recursive, interesting. So calling itself until it hits the base case?
Yeah, exactly. And
Yep.
for 0 returns 1. Classic recursive definition. And the docstrings were pretty good. Quite detailed about what it does, the input, the output.
Right, that recursive approach often looks elegant, very mathematical. Maybe hints at like a training set heavy on CS theory examples.
Could be. Now, Cursor, same prompt. It went a different route.
Oh, how so?
It generated an iterative solution. Used a standard for loop.
Okay, iterative, looping through.
Yeah. And it also included type hinting, int, int. Explicit about the types.
Ah, good practice. And doc strings, too.
Yep. Clear docstrings there as well.
So 2 different ways to solve the same problem. Recursion versus iteration for factorials. That's actually a common discussion point in Python, isn't it?
It is. Recursion can be readable, sure, but Python isn't always great with deep recursion.
Right, you can hit limits, stack overflows. Iteration is often, well, safer or more robust for really big numbers in Python.
So Cursor's choice might be seen as more, pragmatic, maybe focused on avoiding those potential pitfalls.
Could be. Or just a different pattern learned from its data. But the key thing is, both actually worked, right? Both fulfilled the prompt.
Absolutely. Shows that even for simple stuff, these AIs can have different opinions on how to code it.
Okay, so simple functions, check. What about something a bit more web-devy?
Right. We stepped it up. Task 2 involved JavaScript and Express.js. That really common framework for building web apps and APIs.
Makes sense. A very practical test case. What was the prompt?
We asked them to. Write an Express.js API endpoint that listens on the user's route and returns a JSON array containing 3 mock user objects, each with ID, name, and email properties.
Okay, so setting up a basic route, defining some data, sending it back as JSON, standard stuff for an API. How did Windsurf handle that?
Windsurf did pretty well. It gave us a functional endpoint. Included the require express, set up the user's route.
Got the mock data array in there?
Yep, 3 users, ID, name, email, use res.json to send it back, and it even included the app.listen part to start the server. Basic, but functional.
Okay, so it understood the core request, but maybe lacking some extras, like error handling.
Exactly. No error handling, no middleware mentioned, just the bare bones to make it work. Which leads us to Cursor. Because this is where it got, really interesting.
What did Cursor do differently?
Same prompt, remember. Cursor also generated a working endpoint, required express, defined the user's route, had mock users. Slightly different names. Alice, Bob, Charlie this time.
Minor detail.
Minor detail. But the big difference, it wrapped the main logic, the part creating and sending the JSON, inside a try.catch block.
Ah, error handling, straight out of the box.
Right. Even just basic error handling like that, that's a pretty significant step towards, actual usable code, isn't it?
Absolutely. That's crucial for production. If something goes wrong inside that route handler, maybe generating the data fails for some reason.
The try.catch stops the whole server from crashing.
Exactly. You can handle the error gracefully, maybe send back a proper error response. It makes the whole thing much more robust.
So Cursor definitely seemed a bit more, production aware on this one.
It certainly seems that way in this instance, yeah. Including that error handling suggests maybe its training data emphasizes those kinds of practical considerations more. A definite point for Cursor there.
Okay, so one more comparison. We pushed them a bit further again into more structured, object-oriented territory. Java this time.
Java classes, okay. Data modeling.
Yep. We asked for a Java class to represent a user, Specifically,
Yes.
.ed, username, email properties, and crucially, a method to validate the email address.
Right, so not just data storage, but some logic to the validation part. Let's see, Windsurf first.
Windsurf delivered a complete Java class, private fields for ed, username, email.
Standard practice. Encapsulation.
Yep. Had a constructor to set them up, getter methods, get ed, get username, get email, for access.
Okay, all the basics of a Java bean or POJO.
And it included the validate email method. And guess what it used?
Let me guess. A regular expression.
You got it. A regex for basic email validation. It even included a little main method with a sample user to show how you'd use the class and test the validation.
Pretty thorough then. Covered all the requirements. What about cursor?
Well, this is where it gets kind of amazing. Cursor's output was strikingly similar.
Really? How similar?
Very similar. Same structure. Java class, private fields, constructor, getters. It had an email validation method too, though I called it valid email instead of validate email.
Okay, slightly different name. And the validation logic.
Also use a regular expression.
Yeah.
And the regex itself was like almost identical to Windsurf's.
Wow. Okay.
Also included a main method for testing, just used a slightly different variable name for the sample user, example user. But functionally, the classes were virtually the same.
That's actually quite revealing. For a more complex task like this, involving class structure and specific logic like regex validation, getting such similar results.
What does this suggest to you?
Well, it strongly suggests both tools have a really solid grasp of core Java concepts and common patterns. They both understood how to structure the class, implement getters, use a constructor, and how to tackle email validation using a standard technique like regex.
The minor differences, method names, variable names in the test code, seem pretty insignificant compared to the overall similarity.
Exactly. It shows they can both handle this level of complexity pretty competently, generating structured, functional code based on the prompt.
Okay, so they can definitely generate code. Simple functions, APIs, even basic Java classes. Different languages, different complexities, that's clear.
Yeah, the capability is there.
But,
Oh.
and this is a big but, just generating code that runs isn't the whole story, is it? What about, code quality? Debugging, how does this fit into a team?
That's such a critical point. Just because the AI spits out something syntactically correct code that doesn't immediately throw an error doesn't mean it's good code.
Right. It can be inefficient, hard to read, hard to maintain.
Or it contains subtle logic bugs. So that human oversight, the developer review, it's absolutely essential. You cannot just take AI code and blindly trust it.
Treat it as gospel, yeah.
No way. You need a thorough review. Does it meet project standards? Follow best practices? Are there security holes? Performance issues? That human judgment is still key.
And what about when things do go wrong?
Yeah.
Debugging this stuff must be different.
It really is. When you debug your own code, you're trying to follow your own logic, right?
Mm-hmm.
When you debug AI code, you're trying to figure out the AI's logic, which, well, it's not always obvious why it did something a certain way. It doesn't leave comments explaining its thought process.
No kidding.
So it demands a really rigorous approach. You need thorough testing, more edge cases, different kinds of inputs the AI might not have considered.
And probably quite a bit of refactoring, too, like rewriting bits to make it clearer or fit better.
Oh, absolutely. Critical review and refactoring become super important. That analogy we used before, pair programming with a very fast, sometimes opinionated,
and occasionally wrong junior developer.
Exactly. That really sums up the relationship you need to have with it. It assists, but you guide and correct.
And then there's the team aspect. If everyone starts using different tools, or even the same tool differently, what happens to collaboration?
Yeah, that introduces some real challenges. Consistency is a big one. Imagine one person using Windsurf, another using Cursor, maybe someone else using prompts slightly differently.
You could end up with a real patchwork code base, right?
Yeah.
Different styles, different approaches, all mashed together.
Totally. And that makes it harder for everyone to understand, harder to maintain, and probably leads to more bugs down the line.
So version control, like Git, must become even more crucial.
Hugely important. You're not just tracking human changes anymore, you're tracking AI changes too, which means you need to be even more disciplined.
Like committing, often writing really clear messages.
Precisely. Clear communication in the team about how these tools are being used is vital. And those commit messages need to be descriptive, especially if you're modifying AI code.
Can you give an example?
Sure. Instead of just fixed bug, maybe something like refactored AI-generated function get user data to handle null inputs correctly and improve readability. That context is gold for the next person looking at the code.
Makes sense. Oh, no. So let's try and wrap this up. Windsurf and Cursor, they definitely show they can generate code. Python functions, JS APIs, Java classes, varying complexity.
Yeah, the potential to speed things up, especially for boilerplate or standard patterns, is definitely there. It's quite impressive, actually.
And we keep coming back to this, they're not replacing developers anytime soon.
Not at all. They're tools, powerful assistants, but not replacements. Understanding the real requirements, designing the overall solution, making architectural decisions, collaborating.
All still firmly in the human domain.
Absolutely. These tools can augment our abilities, maybe free us up from some of the more routine coding tasks.
Allowing us to focus on the harder problems, the more creative aspects.
Exactly. Think of them as force multipliers, helping us build things faster or better, but still needing that human guidance and expertise.
So that brings us to a really interesting thought for you, the listener, to mull over.
As these AI tools get better and more integrated into how we work every day, how is this changing relationship between us, the developers, and the AI going to reshape how software gets made in the future?
A really fascinating question, and something we'll likely keep exploring. Now, next time on the Deep Dive, we're shifting gears slightly to look at another really practical angle.
The money side.
The money side. We'll be digging into the cost implications of actually using these AI coding tools, pricing models, potential productivity boosts, the long-term financial picture.
Yeah, because adopting any new tool has costs and benefits to weigh up. That'll be a good one.
It should be. Definitely join us for that next time.